What's up everyone? Today I'm going to be talking about every module that I took as a maths student at the University of Exeter doing an integrated masters. So from first year all the way through to fourth year, every single module, and I'll say a little bit about each one. Some of them, especially in first and second year, are very much like what they say on the tin, so I probably won't go into too much detail about those. But I'll be talking about how I found the modules, what kind of thing we studied in them, whether they were hard or easy, what the assessments were like, all of that good stuff. Alright, let's do it. So I'm going to start with my first year modules and work my way chronologically through until my final year modules. To give like a quick overview, at my university, which is the University of Exeter, we mostly, when I was there, had 15 credit modules, and you had to take 8 15 credit modules a year. So usually that was done 4 in term 1, 4 in term 2, and then there were no lectures in term 3, it was just exams. Some modules are 30 credit modules, so they go over both terms. I think the only time I ever did that was my dissertation, which went over both terms, but I know that since I did first and second year, they've now changed a couple of the modules to kind of group them together, so they don't have the same, well, some of the titles have stayed the same, but some of the titles have changed since I was there. That's just a little background for anyone who's watching this who is going to be a student at Exeter. That's why the modules don't have the same titles as I'm going to be saying, but the content is the same. So in my first year, I did the following modules. I had calculus and geometry, that's very much what it says on the tin, and I'm not really going to go into it because I didn't enjoy that side of it very much. I'll be honest, I don't even really remember what else was in that, but it was very much like geometry. We had a module called numbers, symmetries and groups. This was like my first introduction to kind of proofs. I think proof by induction is examined at A-level. It might only be in further maths A-level. Speaking of which, you don't have to do further maths A-level to do maths at university. That is a common misconception. Some people have it, some people don't. It doesn't affect how well you'll do at university, so yeah, if you can't do further maths, don't let that put you off trying maths at university. But yeah, numbers, symmetries and groups, this was a bit proofy, in a style that we hadn't really seen at A-level before. It's to do with groups, which is a mathematical structure, and talking about like permutations, different types of groups. It was kind of like an introductory module into what university maths is usually like. In term 1 I also had a programming module, which was in MATLAB as a programming language, and I had never done any programming before I started university, and this was a hard module for me when I started. It's in term 1. It's literally like one of the first things you do when you start maths at Exeter. I just found it so hard. It was very sink or swim, but now that I felt like it set me up quite well for future modules, because it was my first exposure to what university coursework is like as well, which is much more intense than a homework at school. So yeah, I don't know, I found the programming very difficult, but in retrospect, like objectively it wasn't too hard. It was just that I had never done it before, and it also did set me up very well for future modules, so I'm glad that I persevered with it. With any kind of programming, there's always labs where you can go talk to a lecturer, or you can just work on it for an hour, and there'll be a lecturer and usually a couple of older students, like PhD students, who are there to answer your questions or help you if you're getting a bit stuck. So yeah, it is very difficult, but there's a lot of help available, which I definitely used every single resource I could find for that. I just found it really challenging. Anyway, so that was programming in first year, and the last module we took in term 1 was probability and discrete mathematics, which was like a little bit of set theory and a little bit of probability. And that was term 1. So term 2 started to get a little bit more interesting for me. So we did a module called vectors and matrices, which had a tiny bit of logic in it, like logic tables, which was my first introduction to that, and I really enjoyed it. And then after that it was a lot of like operations on vectors and matrices. We also had dynamics, which was not my favourite, if I'm honest. It's a bit more of the mechanics side of maths. Like if you did mechanics at A-level, it's like a continuation of that. I don't know, it's not my favourite area of maths, but it wasn't bad at all. And all of these modules were pretty well taught. We had advanced calculus in term 2 of first year, which I'll be honest, I hated that, but that was also very much like, you know, integration and that kind of thing. Calculus, but hard. Basically, although there's definitely some overlap with further maths in both that and the calculus and geometry module in first year. There's definitely overlap, so not that you have to have done further maths, but if you have done further maths you'll have seen some of the stuff before. And the last module we did in first year was a module called mathematical investigations, which was a group work module, and it's now combined, I think, with the programming and the dynamics module. I think they grouped all 3 of those together, so you do all the content we did, but it's just like all merged together. I did not enjoy the group work module. I mean, with groups there's always a risk, like with who you get put with, but I did meet 2 of my very good friends doing that, so it wasn't like the worst thing in the world having to do a group project, but it was a bit stressful. Although, I mean, you have to do group projects sometimes at university, so I guess the sooner you get used to that, the better. So that is all my first year modules. I'll put all the titles up on the screen again for a minute. Like I said, in terms of difficulty, I personally struggled more with the calculus ones, which is weird because they're the ones probably that overlap the most with A-level maths. But it's just who I am as a person, I guess. I'd say they're all a pretty similar standard, although definitely if you've not done programming before, that's something that you might have to work quite hard at, or you might just be naturally great at it, but I personally wasn't. I had to work quite hard at that. So that was first year. Moving on to second year. In second year, again, the modules were quite like technical. First and second year are very much about building up skills. The first year modules didn't have the most exciting names, and neither will the second year ones, but in third and fourth year you do a lot cooler stuff like cryptography and option pricing, and like you can really see where it starts to apply. Anyway, slight detour. Second year modules, we have term 1, it was analysis, differential equations, statistics, and one more which I have not written down. I can't remember what it was. I'll put it up on the screen. So analysis is like limits and sequences, that kind of thing. Differential equations is differential equations, and that is really important like in a lot of modules later on, but I found that module so difficult. That's maybe, at the time that I was doing it, that's probably one of the hardest modules I ever did at university. Like objectively it's not too bad, but just like where you are at the time. And the exam as well, everyone does really badly on that exam. But in first year, by the way, all of the modules were just exam at the end, except for the group work modules. But in second year, all of the modules were a 20-80 split between 20% coursework, 80% exam. So a maths degree is very exam heavy. I think the exams that I've taken that are worth the least are like 60% exams, which are still a huge chunk of your grade. So if you don't like exams, like maths at Exeter is not for you, because those really do decide your grade. But if you like exams, that's great. Statistics, it's just statistics. I don't really know that there's anything really to say about that. It's kind of self-explanatory. Term 2, there was linear algebra, which is to do with like, there's a lot to do with matrices and linear transformations and eigenvalues and that kind of thing. Groups, rings and fields, which is, this is the module with the highest fail rate, I think, in the whole maths department, or if not the whole College of Engineering, Maths and Physical Sciences. At least that's what we were told by the lecturer. But I really liked this content. I think that kind of thing, like they say that to kind of scare you into working harder maybe, but I don't know, I feel like with maths, or maybe with anything, like it doesn't really matter what the hard modules are, it just matters what you're interested in, because I personally found that module nowhere near as difficult as like differential equations, for example, but it had a much higher fail rate, so it just depends on you. What I'm trying to say with that is that don't not take a module that you're interested in because someone said it's really hard. Like, you might not find it hard. Everyone has a different experience with it depending on what their personal strengths are. It's basically where I was going with that. Anyway, back to the modules. That one, groups, rings and fields, I really enjoyed. It was literally about groups, rings and fields, which are mathematical structures, and like homomorphisms, isomorphisms. It was quite proof heavy, but I quite liked that. And yeah, statistical modelling is the next one. This is really applicable. This is the first time, I think, at university that you do something that's like directly applicable to a lot of different industries. I can't remember if it was this year or the year after, but we did a case study on the Titanic to see if like different socioeconomic factors would make you like more likely to survive or not. I don't know, this one was really, we did a case study with a spacecraft about the fuel cells, about whether they were like more likely to fail or not in different conditions. I don't know, it was a really applicable module and I found it difficult, but I don't think it was objectively difficult. I think I just found that slightly harder, and we used R, the programming language, to do the statistical modelling. Lastly, vector calculus. I hated vector calculus. This is so not my thing, which is really a shame because it leads on to like fluid dynamics, which is all the astrophysics-y stuff, which I really like the idea of, but the actual maths I hated. I hated this. It's literally calculus and vectors. It's like all integration and stuff, but with vectors, and you know, like grad, div and curl and all of that. I don't know, I just really struggled with that. But that's just me personally. And that was all of my second year modules. Moving on to third year. My battery is about to die, so I will see you after a battery change for third year modules. Here are my third year modules. So this is where it gets a lot more interesting. All of your modules are optional except for a research project that everybody has to do, but even that you can choose like what you do it on. So this is the first year that it's completely your choice to tailor your degree however you want. Up until this point, first year modules were all compulsory. Second year modules, half of them were compulsory, half of them were optional, but there weren't a lot of maths choices. When I took it, at least there were 5 options and you had to pick 4 modules. So unless you wanted to take modules outside of the maths department, which you can totally do, and I did do that in third year, there's not an awful lot of choice before third year. In term 1, I did, from the maths department, I did statistical inference, number theory and the research project, and from the computer science department I did a data science module called learning from data. So starting with the computer science one, learning from data is a Python programming module, and it's data science, so you learn about machine learning, neural networks, clustering algorithms, that kind of thing. It's 40% coursework, 60% exam. The exam is completely theoretical, and you also don't really, if I remember rightly, there was no like working out. It was essay based and it was purely explaining concepts, which I really liked. That's the best exam. I mean, I haven't got my results yet for this year, but up until right now, that's the best mark I've ever had on an exam. I thought the exam was really nice, that style of exam, but the coursework was the hardest coursework I've ever done, hands down. The time that it took to do one 20% coursework in the programming department compared to like a 20% coursework in the maths department, it might just be that I didn't have as much programming background, obviously, as a computer science student, so I was kind of at a disadvantage with that. It took so much time. Like, even remembering it now, I can't believe how much time I had to put into those to make them good. Data science is a really hot topic right now, and it was such a good, like, I wouldn't even call it an introduction because it was quite thorough, but for me it was my introduction to it. I had never done data science before that. I had done statistics, but I hadn't done data science, like clustering algorithms and neural networks and AI and that kind of thing. So yeah, it was a struggle, but it's definitely the one that I'm most proud of because I had to work really hard to get the mark that I got in that. Harder than I've ever had to work in any other module. But yeah, if you're a math student and you take a computer science module, it's a whole different ball game doing programming in the computer science department than doing it in the maths department. So yeah, that's my word of warning. But you can totally do it. I had never done programming before university, so if I can do it, you can definitely do it. Anyway, that was the data science module, and like I said, I'm really glad that I took it. I think it's going to be really applicable in my career after university, so it was the right decision. Yeah, and the modules that I took in the maths department in term 1, so this is alongside that computer science module, they were statistical inference, which is very, again, what it says on the tin. So we were learning like, what did we learn? I sound like such an idiot right now. There were lots of methods to learn, which is unusual. Usually at maths at university, you're taught concepts and then you go away and sit an exam, and it's like questions that you've never seen worked out before, or like proofs that you've never seen before, but you were taught the concepts you need and you kind of like build it up in the exam. Whereas this one was much more like, there were definitely methods we were taught in this one. Number theory, so this is maybe the kind of maths that you think of when you think university maths. Like if you think Fermat's last theorem and that kind of thing, that's more the kind of maths that you do in number theory. It's very proof heavy. You start off by learning, it's about like prime numbers. You do like a very specific case of Fermat's last theorem. You look at Pythagorean triples and prove a couple of results to do with those. I really enjoyed this module, but it was hard. Like, it was a hard module and very proof heavy, like I said, very Exeter specific. But if you're an Exeter student and you're taking number theory, you need to not only have done all the tutorial sheets, you need to have the answers memorized for when you go into an exam, as well as like every theorem, every proof, like basically everything. You have to memorize so much for this module. In an exam, there just isn't time to work out some of this stuff from scratch. Like some of it you have to go into the exam with it memorized. And especially like theorems and concepts and all of that, if you haven't gone into the exam with that memorized, you can't even begin to answer a question. So that kind of goes for most maths modules actually, that there's a lot of memorization involved. There's a lot more memorization involved than you would think for a maths exam, because it is so proof heavy. But yeah, especially for this one, knowing the tutorial sheet questions will give you a massive advantage. Like, they don't necessarily exactly come up, but to give you an actual example of what happened in my exam, this is for number theory. We had a question that said prove that the product of three, so if you have a Pythagorean triple, x squared plus y squared equals z squared, prove that the product xyz is divisible by 60. So you kind of look at that and you think like, okay, what facts do I know about Pythagorean triples? Like, what did we prove in lectures or whatever? My year, which is the year obviously that question was asked, we had a tutorial sheet question which was prove that the product is divisible by 3 and prove that it's divisible by 5. And we had studied in lectures, we had done a proof to show that for every Pythagorean triple, at least one of them is even. I think like one of them is even, one of them is odd. I don't really remember the result, but definitely one of them is always even. So like from that, you have a 2 dividing it, a 3 dividing it, a 5 dividing it. That gets you to 30 already, and I don't remember where I found the other 2. But that's an example of like, if I hadn't remembered that those tutorial sheet questions were like relevant, it's not the kind of thing you can just come up with. I mean, unless you're a lot smarter than me, but for me personally, it's not the kind of thing that I'm gonna come up with in like 10 minutes in an exam. I have to go in with that information. Anyway, that was a whole detour to say that if you're an Exeter student, be sure to have your tutorial sheet questions. You've gone through them enough times that if it comes up in the exam, you can do it like perfectly, because those are exam marks that it's really annoying not to get when you've seen the question before. So anyway, the last module I did in term 1 of 3rd year was my research project, which I really enjoyed. This one, I did it on astrophysics. It was the solar dynamo and space weather, which, okay, so after everything that I said about vector calculus, you're probably thinking like, why would you do that? Basically, I do hate vector calculus like deeply to my soul. I hate it, but I'm so interested in space that like I was willing to put up with a bit of vector calculus to be able to read about that kind of thing. The way the module was assessed is that you did 2 kind of research paper style essays and a group presentation. And yeah, I just really enjoyed it, and I was so willing to put up with having to do a bit of this vector calculus math and having to struggle with that for a bit, if it meant that I could read about like all these really cool like cosmic ray things, and the solar dynamo, which is the magnetic structure inside the sun. I'm not saying that I'm not willing to work hard on something even if I don't enjoy it. You have no choice but to do that at university. There's always going to be modules you don't enjoy that you have to take, but I personally just find the whole experience of putting that many hours in studying so much more pleasant if I am interested. So yeah, I really liked it, even though it wasn't my strongest area of maths, because I was so interested. How many times did I just say interested? So that was my third year research project, and in term 2 of third year, this was my favourite term that I've ever had at university. Actually, third year was the best year by far. There was so much choice. It was such a good year. But my term 2 modules were cryptography, combinatorics, stochastic processes, and advanced statistical modelling. Just such a beautiful term. Really like the peak of my university career. These modules I cannot recommend enough if you're an Exeter student. The lecturers, fantastic. Like the module content applicable to so many more industries than you would think. It was such a good time. It was such a good time. I'm getting emotional just thinking about it. Again, I think these were all 20% coursework, 80% exam. The research module had no exam, but that's the only time that I've, other than my dissertation this year, everything else has an exam, which is weighted very heavily. But yeah, so going into slightly more detail with those modules, cryptography, possibly my favourite module I've ever done at university. It was well taught, it had really good like material and everything. Actually, most modules have good material, especially before 4th year, because in 4th year I took some quite niche modules, but definitely 1st and 2nd year there's loads of really good material. Lectures are all recorded at Exeter. Anyway, back to, that was a tangent, back to what I was saying about cryptography. This is like the application of group theory in like applied maths. Group theory applies a lot within pure maths, but in terms of like outside of maths, I don't know if I'm phrasing this right, but like this is the real world application of group theory, is cryptography. This is when you send a text message and it's encrypted, or when you connect to a website and it says like HTTPS. That is cryptography. It's using encryptions to keep your data safe. And this module, like, we learned a little bit about the history of cryptography, but that wasn't examined at all. It was very like the exam was like breaking encryptions and like coming up with encryption systems, and we studied a lot of existing encryption systems to see like mathematically how they worked and how you could break them, and like what their flaws were and how they compared to each other. It was just fun, like a puzzle to solve rather than like integrate this again. Do you know what I mean? Anyway, as you can tell, I really liked that module, and the exam for that, sorry, the coursework for that was Python programming, where you had to write like encryptions and that kind of thing. Although I think some of the coursework was theoretical as well, and the exam was completely theoretical. If I hadn't done the computer science module, that would have been the first time I had done Python, so I was quite glad I'd had some exposure to it already when it came to that. But I mean, if you haven't had exposure to Python or MATLAB or R before, that's also fine. Like there's a lot of support at Exeter with programming, so I wouldn't worry about that. Just because I worried about that, so that's why I'm saying it now. Anyway, that was cryptography. Very fun, very like puzzly, which I enjoyed. Combinatorics, this one I never know how to describe, because it's counting things, which sounds like not a university level thing to do. It's useful in like probability, to like figure out the different outcomes in things. It's useful in like strategy games. If you ever did maths challenge or that kind of thing, this is more of that kind of question where you have to kind of puzzle something out. I don't know, I really enjoyed that one. I would recommend that. Stochastic processes, this was taught by my favourite lecturer at university. I had a couple of really good lecturers. It was tough competition for the top spot, like in my head, of who my favourite lecturer was, but this one wins. It was such a fun module. It was about, like, basically stochastic processes means time dependent processes, so anything that is a process that changes over time, like for example the growth of a population, the spread of a disease. Wow, those are the only two I can come up with right now. We did Q theory, which doesn't sound like the most fun thing when I just say it out loud, but Q theory is actually really interesting. I don't know, like on the M25, I'm using the M25 as an example because I live in London, but on the M25 sometimes they'll reduce the speed limit to like 50 instead of 70, and it gets people where they want to go faster, because queues travel backwards over time, not like a crash queue, but just queues, like for no reason, will travel backwards because it's to do with people's stopping times. If you're driving faster, the stop-start is more dramatic, so it creates queues behind you when lots of cars are doing that. I don't know, maybe it's only me who finds that interesting, but I thought that was quite interesting. And we also did Markov chains in stochastic processes, and we did a little bit of game theory. We did Gambler's Ruin. I don't know, I just thought it was, and like coin tossing games and that kind of thing. I really liked this module, and it's the best taught module. The last module we had in the third year was Advanced Statistical Modelling, which was just more of statistical modelling like I talked about in the second year module. Which again, great lecturer, really well taught, really applicable in real life, so interesting. I can't say enough good things about my third year modules, especially the term 2 ones. Whew. So that was third year. Moving on to fourth year, this year that I've just completed. This year was hard, and this is like the master's year, so if you do just a normal 3-year course, you can do all of the modules that I just talked about. In the fourth year, the people who just join for 1 year, who do like the separate masters to the integrated masters, I think you can take all the same modules I took. I think there are even a couple of modules that you can take that I couldn't, because I had done some third year modules that kind of covered that content, so because of the overlap we weren't allowed to do them. So yeah, I think you can take all the modules that I'm going to say now. And yeah, I found them hard. And I also found that there was still a lot of choice, but there were less modules I wanted to do in fourth year, especially because I hadn't gone down the fluid dynamics track, so I couldn't take any of the space modules, which there were quite a lot of astrophysics-y ones in fourth year that I couldn't do, sadly, although also not sadly, because I hate vector calculus, as we all have established by now. So I had a dissertation in fourth year, which was over 2 terms. It was worth a quarter of my grade for the year, and it was on elliptic curves, which is a very pure maths thing, but I also talked about theoretical applications to post-quantum cryptography. And I mean, I liked my project, but it wasn't like the same kind of interest that I had in the astrophysics one. Definitely the parts of my project that I think I've done best on are like the cryptography parts, because that was completely like, I asked my supervisor if I could look into that. That wasn't part of what the proposed project when we were picking our projects was. So that was definitely, I think that's probably the bit that I'm going to have done best on, because it was the bit that I was really interested and willing to spend a lot of time figuring out. The rest of my project was very pure maths, and I basically picked it because I thought that's something that I'm stronger at, which I usually do get stronger marks in that kind of maths, but I just found it less pleasant to have to work so many hours on something I wasn't, like, I didn't hate it, but I didn't love it. And I don't know, for a project that I could pick myself, like, I don't know why I didn't do something that I really love. Although then again, there wasn't like something that called out to me, so that's why I'm not doing a PhD. But anyway, yeah, that was my project. And for anyone wondering how the project picking process is, because I did the integrated masters, we picked our projects. We were given a huge list of all the possible projects and all the lecturers willing to supervise at the end of third year, and we kind of picked over summer. We had to email lecturers if we were interested. That's how that worked. We called it a project, like a research project at my university, but it is like a dissertation or a master's thesis or whatever you want to call that. Like, it was an independent research thing with weekly supervisor meetings and all that jazz. Yeah, that was my project. Mine was, by the way, 100% my project, like my essay. It should have been a 10% Viva, 90% project, but the Viva got cancelled because of everything happening at the moment, so I haven't got my mark back for that, but it is 100% like that one essay, and it was like a 50-page essay, so like a solid chunk of work. The modules that I took in term 1 this year were logic, models and sets. We started off with propositional and predicate logic. That was like the first half of the module, and the other half of the module was model theory and set theory, which really I found quite difficult. This whole module, one of the difficult aspects of it was that we had to learn a whole new like language to do it in. Obviously maths, you learn how to, you know, there's a lot of symbols that you have to learn how to write maths, which you do a lot of learning that in first year, but for this specific module there's a lot of terminology and a lot of notation that we had never seen before, so just getting your head around that is a bit difficult to start with. And yeah, the model theory and the set theory stuff really just blew my mind. Like, it was it was quite like mind-bending stuff to get your head around, at least for me. We studied results like the Real-Niczewski theorem, axiom of choice, and equivalence, that kind of thing, building inner models inside models. I don't know, it was hard, but that's the kind of thing we studied. Lots of models, lots of sets. The exam for logic, models and sets is the hardest exam I've ever done at university. It was really hard, but it was only worth 70% of the module, whereas usually exams are worth 80%, and the other 30%, instead of being a coursework, which I realise now I haven't really said what those are, but they're basically an exercise like a problem sheet. So yeah, when I say coursework, that's usually a set of problems that we hand in during term, and this one didn't, it had problem sheets but they weren't for credit. The 30% that wasn't the exam was quizzes online. There were 3 quizzes, or no there weren't, there were 5 quizzes worth like between 5 and 10%, and it was multiple choice, and it was open book, but it was still like, some of it was still quite hard. I actually quite liked the quiz testing format compared to the coursework assessment format, because quizzes take less time, for sure. Like, it takes less time to prepare for a quiz than it takes to do a coursework. The other module that I did in term 1, or the other 2, how many have I talked about? The other 2, so one of them was algebraic curves. I've literally just sat the exam in it, but I can't even remember what it was about. Lots of algebra, lots of curves, Hilbert's Nullstellen Satz, if anyone knows about that. Lots of stuff about ideals, and this does like carry on from the group theory and the number theory side of maths, so I picked this thinking in theory I'd be quite good at it because those are where my better grades are. But this was hard. But on the other hand, it was really well taught. It's one of my favourite lecturers who taught this one, and yeah, I would definitely, if the same lecturers who were doing it, I should say with all of mine, the lecturers sometimes change, so please don't pick a module just because I said like the lecturer is good, because it might, this is why I haven't really said very much about lecturers, because they changed sometimes from previous years. But yeah, the algebraic curves lecturer was one of my favourite lecturers at university. It was really well taught. The last one that I did was dynamical systems and chaos. This is not my favourite kind of math. This one was all about like finding equilibria in systems and finding and like drawing bifurcation diagrams, and what kind of conditions lead to chaos, that kind of thing. If you're into that, this is a good module, like it was well taught and everything. I'm not particularly into that. I took this module because I had no other choice for this term, like there were no other modules that I was interested in or could do or anything like that, so I just took it. And I mean, it's definitely useful, it applies to a lot, but for me personally it's not my thing. Term 2, we had a module called Advanced Probability Theory, and this module has run before and I think it will run in future, but my lecturer my year is the only year he's teaching it, and he kind of did his own thing with it, so it won't be like it won't be taught how it was taught to me in future. So there's kind of, I don't know if there's really much point in me saying like how I found it or anything, because like no one can take this module again, at least how I had it. But the kind of maths that it was, towards the end, a bit to do with martingales, which links to the option pricing and financial side of math. We studied a lot of big results like the dominated convergence theorem, but yeah, just very heavy on the theory. Yeah, it just wasn't for me, it wasn't my thing, which is a shame because I did really like probability and statistics in school and earlier at university, but I didn't really take my degree in the statistics direction. You can kind of take it more statisticsy or more fluid dynamics, you can take it more of a financial direction. I kind of dabbled in everything, but I very much like went down quite a pure maths route, group theory kind of modules whenever I could. So yeah, I did end up actually doing quite a lot of statistics, but in 4th year the probability theory one was the only one that I did, and it wasn't really for me. But that's just me personally. Mathematical theory of option pricing, I would heavily recommend this one if you're picking your 4th year modules. This was really well taught, really well structured. There's a little bit of MATLAB programming in it, and the exam is completely theoretical. The stock market, shares, different ways of buying and selling shares, different kinds of contracts you can have, how time can affect them, modelling the processes, because they're all stochastic processes, and we did a lot of stochastic calculus. You have to be comfortable with like some really nasty equations, but like they're really well taught in lessons. There's so many exercise sheets and tutorial sheets and books available online. Actually, for most of the modules they'll give you a reading list, and most of the books you can get through the university online for free. Yeah, I really enjoyed option pricing. I think it's one of the best modules I took, and I would very much recommend that one. All about financial reasoning, pricing options, a bit of stochastic calculus like integrations and stuff. It was a solid module, really liked it. And the very last module, sorry this has been like the longest, most rambling video ever, but the last module I took in 4th year was actually a 3rd year module, because you can take modules from lower down. Basically you can do one module a year that's from the year below. I had never done that up until this year, but I felt like as it was my last year I could give myself a bit of a break and take a 3rd year module to kind of lower the workload a little bit. And this was a module called Graphs, Networks and Algorithms. Really enjoyed it. We spent a lot of time studying a couple of different algorithms on graphs. The assessment for this was 40% quizzes, 60% exam. The quizzes, if you watch my university vlogs, I talked about them a lot because I had to do like them every week, so it was always on my mind. Basically you just prepared in advance like how to do an algorithm, and then you went to the quiz like on in a computer room. You were given like a graph with weighted nodes or whatever, and you just applied the algorithm to that graph. We touched a little bit on like the complexity of algorithms, kind of did some analysis on algorithms, but it wasn't a computer science module. It was like very much a maths module that touched on a couple of computer science ideas when we were looking at algorithms, but it was very focused on like the mathematics behind the algorithms. I just really liked that module as well. It was one of my favorites. So I think that is everything. I think that's every module that I took at university. I hope this was useful. I hope this gave you a little bit of insight into what modules are available at Exeter specifically, or if you are doing a maths degree, what you can expect, or if you're not doing a maths degree and we're just curious. I hope this has satisfied your curiosity as to what people actually study in a maths degree. Don't forget to like and subscribe if you enjoyed the video, and I will see you in the next one. Thank you for watching.